I wanted to do a video on open loop versus closed loop in the CNC world and just give you my experience and how we've evolved in the workshop. So we started life with this particular motor. It's an open loop circuit motor, and with that we used this particular driver. With that driver we used this parallel breakout board. And that was all good. We had that set up and running on a mill, and I thought I was very clever. We had Mach 3 running that, and the first issue really came about when we wanted to upgrade the PC and replace this breakout board with a USB board. So we used the smooth stepper USB board, and I had nothing but troubles with this board. I had earthing issues and I could never get it to run consistently. And so what that meant is this one went out again, and we bought back the parallel breakout board. That's really left me with the feeling, even today, that parallel breakout is the only reliable way to go, even though some people have moved to Ethernet. Now the next thing that happened was we started noticing inconsistencies in our work, and especially inconsistencies with accuracy. So at the time I just thought, well, this is all cheap Chinese stuff, and we're losing steps, so I need to go down the closed circuit path. So to do that, we had to move away from Mach 3 and we had to go to Linux CNC, and then we had to work out some way to have encoder feedback. So that left us with two choices. We could either go the Mesa board, or we could go the Pico Systems USC board. And we went the Pico board. This is a fantastic board. It can do many things. It can take in anything with a pulse, really. So it can take in encoders, linear encoders or rotary encoders, and it's really designed around Linux CNC and interfaces very well with it. So we went this particular board, and for our feedback we chose linear scales. So the linear scales have worked for us for a number of years on different machines, and they've been very good. So this was really our setup, our closed loop setup for some time. But then what happened was we wanted to buy new machinery, and when we bought new machinery, setting up scales is really a fiddly, painful business, and it was much easier just to get rid of the scale and use a rotary encoder on a motor. This is a Chinese motor. It's a copy of the lead shear motor. And a lot of people get this and they plug this into a lead shear controller, but we kept the drivers because I'm not a fan of that system where you plug your rotary encoder into your driver, because to me it's still a blind system. It's not an open system. It's still an open system. It's not a closed system. All you're doing is guaranteeing that you're getting steps from the driver to the motor, and if you're not, well, you wouldn't know if you are or not. So all that said, I prefer to have this plugged directly into the controller itself and manage that controller from Linux CNC. Now that begs the question, well then which is better? Having an encoder on a motor or having scales? And for my money, scales is much better. There's two reasons for that. The first reason is that this slide won't move until the table moves. So even though the motor spins up, this won't necessarily move until the backlash is taken up. And that means that you don't have to worry about backlash or setting backlash, or be concerned with the backlash that may vary across your ball screw. So that's the first real advantage of a scale. And then the second advantage is in the resolution. So this is your standard 1000 resolution scale, and this is also a 1000 resolution encoder. Now, this encoder is actually 1000 resolutions per quadrant. So 1000 by 4 means it's 4000 steps for an entire revolution. And we have 5mm ball screws here, so divided by 5 is 800 steps per millimetre. So 1 divided by 800 gives you a resolution of 0.00125. This one here, because it's linear, it's 1000 steps multiplied by 5 is 5,000. So you would get an additional 1,000 steps for the same one rotation. And if we go 1 divided by 1,000, it's 0.001 resolution. So this is higher in its resolution, and also this takes up backlash. The downside of this is they're a pain and fiddly to install, and you really have to install them so that the slide is parallel. It's really important this runs parallel on the glass. So then the question becomes, well, which is better, an open system or a closed circuit system? The real answer is neither. The real answer is your ball screw. Now this ball screw is a C7 ball screw, and if you're going to get inconsistencies or inaccuracies when you're machining something, most of it will be in the error across the ball screw. Repeatability is a different issue because the ball screw will generally always return to the same spot, except you might get different backlash depending on your ball screw in different places. So the scales, the linear scales, look after that, which is one of their advantages. Now, this ball screw has been replaced by a C5 ball screw, and if you want accuracy in your machine, it's the best thing you can do. I'd even recommend going to C7 if you can afford that. So the ball screw, it's not so much important whether it's open system or closed system. Ball screw is the most important. That said, would we ever go an open system? The answer is no. There's two reasons for that. The first reason is because it always gives you peace of mind knowing that you know if your steps are happening or not. And the second reason is because it gives you the ability to put other things like spindle encoders on that are, you know, particularly for something like a lathe, a spindle encoder is invaluable. It lets you do constant rate machining, it lets you do threading, it lets you have a closed loop system on your spindle speed. There's many things you can do with an encoder, and to do that you're really going to need either a MESA board or a Pico board running a closed loop system. So I just wanted to put that out there. That's how we've evolved. We only run closed loop systems. We generally only use the rotary motors because of convenience over the scales, but the scales are very good if you want to go to the extra effort of installing them. So hopefully you've enjoyed that. Thank you.